I'm Dr. Anita Rexlin Devraj, Associate Professor of Physics, Amet University. Today, I'm going to explain you about rest and motion in physics. Your favorite hero is there, am I right? He is Cristiano Ronaldo. In the first picture, he is simply sitting. In the second picture, he is just kicking the ball or running with 40 kilometers per hour by chasing the ball. So in these two diagrams, what you are observing? In first diagram, you can easily say he is relaxing, he is resting. But in the second diagram, he is just running. So you can easily say that the first picture is the example for rest. The second picture is the example for motion. Actually, the rest and motion comes under the title of mechanics. Mechanics is basically classified into two kinds. One is statics and dynamics. Statics is the study of objects which are at rest, and dynamics is the study of motion of objects. It should not be at rest. And dynamics can be furtherly classified into two types. One is kinematics and another one is kinetics. So kinematics explains about how the things are moving, and kinetics is why things move with the help of force, by giving force with respect to mass and energy, that and all. But here we are going to see only about what is rest and what is motion and kind of motions as well. Basic definition of rest. Rest refers to an object which is in stationary state, which means it does not change its position with respect to the surrounding over time. Okay, that is called rest. Then motion describes a change in an object's position with respect to the surrounding over a time. You may think in the world or in this universe, every object or every living thing, every non-living thing will be in any one state. It may be in rest or it might be in motion. So what is rest? A body is said to be at rest if does not change its position with respect to its surrounding. For example, the passengers sitting in a moving bus are said to be at rest with respect to the driver of the same bus who is driving the bus, because with respect to the driver, the people or the passengers sitting inside the bus will not be changing their position. They are sitting at the same seat, considered as an example for rest. Then what is motion? A body is said to be in motion if it changes its position with respect to its surroundings over a time period. For example, the passengers sitting or hanging on the steps of the moving bus are said to be motion with respect to an observer or a person who is standing outside the bus or bus stop or on the road. Okay, this is a good example for motion. Now, there is a relation between rest and motion. So, these two are called as relative terms. For example, a passenger sitting in a moving bus is at rest with respect to the driver. Am I right? But the bus is moving. So, the passengers sitting inside moving bus will be considered as a motion with respect to the person who is stand outside the bus. Okay, so the rest and motion will be relative terms now. So with respect to one, we are explaining the other thing. And there are so many types of motion because we are giving some force to make the rest object to move from one place to another place. And different objects move differently. Some objects move in a straight line, some will be moving in a curved path, and some move in other different way. Basically, there are three types of motions. One is translatory motion, another one is rotatory motion, and the third one is vibratory motion. So, two more types are also there, that and all called as random motion and oscillatory motion. And random motion is the movement of any objects or molecules or an atom in a random way. They won't follow any timing or they won't follow any path. And for oscillatory motion, to and fro motion of anything, object or an atom or any molecule. Rotational motion is called as the object should rotate on its own axis. Translational motion is further classified into three types. One is rectilinear, the second one is curvilinear, and another third one is circular. So, rectilinear means the object should be moved in a straight line. If the object is moved in a curved path, that is called as curvilinear motion, and it rotates its own axis. Circular path means that is called as circular one. These are all some other types of motions. Up and down motion, example is seesaw. And straight line motion, train, movement of train in a straight line, or movement of aeroplane in a straight line, or movement of bus in a straight line. And round motion, example is merry-go-round, zigzag motion of snake or atoms or molecules, back and forth motion of swing, pendulum. So these are all a kind of motions. First, we will be seeing what is translatory motion. In translatory motion, a body moves along a straight line. The line may be straight or curved. For example, look at these two images. In the first image, the car is moving in a straight line, which is an example of translatory motion. And in the second picture, the person is riding his bike, but the bike is in a curved path, but it follows a straight line path. So this is also an example for translatory motion. And there are three kinds of translatory motion: linear motion, circular motion, and random motion. In linear motion, the body moves along a straight line. For example, you can say aeroplane flying in a straight line. You have to specifically say straight line, the word straight line, because aeroplane also have circular motion as well. And similarly, you can tell the movement of bus in a straight line. And then go for circular motion. If the body moves in a circular path, then it is called circular motion. So, motion of earth around the sun. Okay. So, this is a good example for circular motion. Then the third one is random motion. So, this is the disordered or irregular motion of an object or atom or molecule, anything. Example is motion of smoke or dust particles in air. Then come to a rotatory motion. The spinning motion of a body about its own axis is called its rotatory motion. An axis is a line around which a body rotates. So, the good example for rotatory motion are the motion of a wheel about its axis and that of the steering wheel are the examples of rotatory motion. The cycle wheel, the car wheel, that and all rotating now with respect to a single axis, and the fan, the earth is rotating. Then the wings of the windmill also a good example for rotatory motion. Then comes to an oscillatory motion. Oscillatory motion is the motion in which the object will be moving to and fro or forward and backward. In playgrounds, you can see the swing and pendulum clock, tuning fork, all are good examples for oscillatory motion. Vibratory motion. When you beat the drum, makes the guitar to play. Those and all examples for vibratory motion. Now you may have a doubt like, what is the difference between oscillatory and vibratory motion? We need to know that clearly. Oscillatory motion refers to any motion that repeats itself in a regular cycle, like the swinging of a pendulum or the back and forth motion of the piston. So, this is called oscillatory motion. And vibratory motion specifically refers to oscillatory motion that occurs around a fixed or equilibrium point, often seen in systems like springs, tuning fork or vibrating strings. That is, all the vibration motions can be an oscillatory motion, but not all the oscillatory motions can be a vibratory motion. That is, the key difference is very simple. If the oscillations are very fast, that is with high frequency, then it is called vibratory motion. If the oscillations are slower, that is low or medium frequency means, then it is called oscillatory motion. Thank you.